So in this video we are discussing about sets. Sets are again similar to maps, but they don't have the key and value pair. So it is just like having only keys, you can consider. It's just like array, right? But there is one advantage here. Again, sets will take, similar to map, it will take only b of log n time. So that is what the advantage of set. There are many advantages, or you can consider that as a disadvantage. So that is, you can store the set elements in set, right? So in set, it will automatically, it will store the elements in ascending order. That is one thing, that property for set, that is the property of set. In ascending order, it will store every elements. So if you want to sort the given array, then you can simply use this set, insert all the elements into set, and simply print the set elements, and it will be working in log n time, right? So obviously log n, actually it will work in log n because you need to insert each and every elements of array, right? So you need to traverse through array. That is why it may take log n time. It will take log n time. But when it comes to set, it will try to reduce the time so much because it uses binary tree, again similar to maps. So another important thing that you can consider as a advantage or a disadvantage is that it will remove all the duplicate element. So it will remove all the if you want to remove duplicate elements, simply insert every elements of the array into set and simply print out the set. It means this output will be in the ascending order, and again you need to there will be no duplicate elements. So again, if the problem says you need to maintain the order and remove the duplicate elements, at that time you can't use this, right? So this is about set. Unordered set, let me explain you that also. So unordered set, again there is no particular order here. Just like unordered map, there is no particular order. It is not the order what we give, and also it is not in the ascending order. So that is what you can remember. And duplicate element is not there even here. Duplicate element is not there here. And when it comes to time complexity, it takes nearly big of one time. So much optimized version of set, but because it uses hashing, right? Hashing it uses. Now let me talk about multi-set. Multi-set will actually, again, it will, one difference from this set and unordered set is it can store duplicate elements, but it will be in ascending order. So you need to remember this ascending order. So you can use any of these three. I'm going to discuss these two because these are exclusively used. So how to create the set? So set, then after that let me insert int values, right? And before that you need a library called set, include set. Now you need to insert element, right? How to insert? There are again two methods to insert. You can use simply, let me call this as method 1, let it be equal to 1, 2, 3. So you have simply created the set. So imagine I will give some duplicate elements called 3, and let me not sort this. For example, let me give 2, then 1, then 4, then 3 and 3, right? It is unsorted and there are duplicates element. That is how I created a set. Now method 2 is again insert. You can use insert what you have done for the maps. So in type of s1, let me call it as s1, then s1 dot insert insert. Here let me give 12, then s1 dot insert insert, let me give 14. So that is how you can second method of creating a set. So let me print it. So how to print it? So again you need an iterator. Of what type you need? I need an iterator of set type. So int, then iterator, let me call it as it, let it be pointing to, or let me use it in for loop. It should be equal to s dot begin, then it shouldn't be equal to s dot end, then IT plus plus. Let's get inside. Cout is dot. But you need to print the iterator. So for that you need to use asterisk, then give some space here, right? So at the end, or you can give endline anything, it's fine. So let me print this. So it should be printing 1 2 3 4 because it need to maintain the order, then it need to remove the duplicate elements, so you make it 1 2 3 4. Now that is how you can print, or you can use the or you can use iterators like auto, that is range based for loop, auto id, let it be pointing to yes, then here I need to print it. So don't use asterisk here. cout, then endline. Now let me run this and it should give you the same result. 1 2 3 4 I believe. So 1 2 3 4, that is what you need to get again. 1 2 3 4. Now what you can do is, you have printed, so in map what you have done, you have printed, you can use again find operators here. So again it will return what? It will return the same element. So find, this case, imagine I will create a or that is iterator, let me call it as, let me use auto here, it1, let it be equal to s dot find define 2. So if you print, it will again print 2. So why this is useful? Because in order to find that element is there or not, you can use it, that is find, right? So you need to get 2 here. So let me show how it works. Actually, let me give some other element which is not there, for example 200. So if that it is not equal to s dot end, as I said how end will work, right? In maps I have said you how that end will work. Else you need to print what? You need to print the element is not there. So if I run, I should get the element is not there because 200 is not there. So after that I can use erase, right? Erase, erase. So here I need to erase this. Let me make this as let me make it as 2 iterator. So it is pointing to some element. I need to erase this element from yes. So how to do that? So simply call it, sorry, you can call yes dot find. Inside that you can give it1. So if you print, you need to check the size, right? Before that, let me check this size. How to check the size? Again, easy, cout yes dot size. It should give you 4. No match for this function. So let's again, I was using this erase, but by mistakenly I have given find. So it has to print size as 4 because I have 4 elements. So let me erase this. So s dot erase s dot erase. So inside that, let me give it1. Next I will print this size again. Let me simply copy this thing. Let me paste this here. And if I run, I should get 3, right? Because I have erased. And at last, what I'm going to do is, again, you are getting 3. Clear. I'm using clear. cl here clear. Here clear. And clear will remove all the elements. Now s dot cl here clear. And now I will print the size again. S dot size. If I run, I should get 0 at last. So this is about, so I'm getting some mistake. So operator is not correct. So if I run, I should get 0 here. So what about unordered map is, so it will not store in particular order, same like unordered map. So how to, so you are getting 0. Now unordered map is there, right? Here unordered map is just like what I already explained you, right? And the time complexity is again most optimized. And how to create it, you need a library called unordered set. Now I need to make this as unordered set. Next iterator I am creating, this should also be unordered set. Unordered DERED unordered set. So if I run, so it should work. So that is fine. Everything is working. You can observe the order. It is not in proper order. So this is about sets. So thank you.